Welcome to Lesson 1, Types of Bonds. Our lesson objectives: identify whether a bond is being broken or formed based upon the energy being absorbed or released, distinguish between the three types of bonds, and classify a substance as ionic, covalent, or metallic based upon its properties. So what is a chemical bond? Chemical bond is a force of attraction between two atoms. So here I have two atoms, as you can see, and you can see that the positive nucleus of one atom is attracting the opposite charge, the negative electrons of another, and then vice versa. So this positive nucleus is attracting the negative electrons of this atom, and this pulling together creates a chemical bond. There are also some repulsive forces going on. We have the negative electrons repelling each other, and then of course the positive nuclei repelling each other as well. And so if you look at both atoms, in this case here, if they have a similar electronegativity, meaning they have a similar attraction for electrons, you can think of it as strength of attracting electrons, then they're going to be pulling on these electrons somewhat equally. And so if you think of a game of tug of war, no one's going to win this game, and so they end up sharing these electrons. And this is a shared bond, which we call a covalent bond. If one of the atoms, like here, chlorine and sodium, chlorine has a much higher electronegativity, so it's got a stronger attraction for electrons. And so when they're pulling on electrons, chlorine will actually take sodium's electrons, and they'll be transferred over. And in doing so, they complete their valence shell of electrons, but now chlorine forms the chloride ion. It has gained an electron, so now it has a negative charge. And sodium lost an electron, and now it has a positive charge. So instead of sharing like we have here, this transfer of electrons creates this positive and negative charge, and then we have an electrostatic attraction between the two. The positive ion attracts to the negative ion. So what occurs when an atom forms a bond? Well, atoms achieve a full valence shell of electrons, that stable electron configuration, when they form a bond, either by sharing electrons or by transferring electrons. So when a bond is formed, energy is released spontaneously. And actually the word we use is exothermic. Exo meaning exit and therm meaning heat. So it's giving off heat. And when a bond is formed, we form a stable compound. So here's an example here. Here is pure sodium here, the metal. This is chlorine gas. And when they form a bond, as you can see here, it's very exothermic. We can see lots of heat being released. And we then form a very stable compound, which is sodium chloride, or table salt. When we break a bond, we have to put energy in. So in order to break something apart, I have to add energy. So energy is absorbed, and the word we use is endothermic. Endo meaning taking in, again, therm meaning heat. And so the stability then decreases. Atoms are unstable. So example, moving two atoms apart, as we can see here, requires the addition of energy. So if you look at this situation, if we have this attractive force on these electrons and they're sharing these electrons, if I want to move them apart, it's like moving two magnets apart. I have to put energy in, and so therefore energy is absorbed. And now they are unstable. If I let them go, they're going to come back together. Let's check your understanding. Can you identify whether a bond is being broken or formed based upon energy being absorbed or released? Now let's look at the three types of chemical bonds. The first one we have is covalent, the next one is ionic, and then we have one called metallic. So a covalent bond, the word co means share, and valent means valence electrons. So they are sharing valence electrons. So as we saw before, when they have similar electronegativity, similar attraction for electrons, there's somewhat equal pull on these electrons, and no one wins this game of tug of war, and so they end up sharing them. And so covalent bonds, sharing of electrons between two nonmetals. The reason why they're nonmetals is because nonmetals have similar electronegativities. And when they form a chemical bond, they form what is called a molecular substance, or a compound. So what are the properties of covalent compounds? Well, they have very low melting and boiling points. This is due to the weak attraction between the molecules. So here's a covalent bond. This is HCl. Here's another one. And these two molecules have an attraction between them. And it's very weak. And since it's weak, it causes a low melting and boiling point. And they also don't conduct electricity due to the lack of any charged particles or ions. There's no charged particles here, and therefore we can't conduct electricity. An ionic bond has the word ion in it to remind you that it is a connection between ions. So an ionic bond is a transfer of electrons from the metal to the nonmetal because the nonmetals have a high electronegativity, a high attraction for electrons. And the metals have a low electronegativity, so they can't hold on to their valence electrons. So when there's this pull on electrons from both atoms, the nonmetals always win, and therefore the electrons are transferred over. And as we saw earlier, it creates a positive ion and a negative ion, and then there's this electrostatic attraction between the oppositely charged ions. And again, ions, that's why it's called an ionic bond. And recall that the metals are on the left-hand side of the staircase here, and the nonmetals are on the right. So whenever you have a metal and a nonmetal, it's going to be ionic bond, and they're going to transfer electrons. What are the properties of ionic compounds? Well, they're hard. They have this crystalline structure, so that they form crystals. They have a high melting and high boiling point because it's hard to break apart that electrostatic attraction, that positive-negative attraction. They are soluble in water. They'll dissolve in water. And they will conduct electricity, but only in water, only when we dissolve them in water, which is called an aqueous solution. And we call ionic substances electrolytes because they conduct electricity. So ionic compounds will separate into ions in water, and they will conduct electricity, as we can see here. So here is the crystal structure of an ionic compound. It's these positive and negative ions connected. And when we put that in water, the water essentially rips them apart. And you can see then that the positive ions are attracted to the negative end of water, happens to be the oxygen, and the negative ions are attracted to the positive end of water, which happens to be the hydrogen. And because now we have these charges floating around, we can conduct electricity throughout this substance. Here's a better picture here. So pure water does not conduct electricity because there's no charged particles. And the solid ionic substance like table salt does not conduct because the positive and negative ions are kind of fixed in this solid structure. It's only when we dissolve them in water they actually break apart, and now we have these ions released in water floating around, and they have the ability then to conduct an electric current. So let's check your understanding. Can you classify a substance as ionic or covalent? Lastly, let's look at metallic bonds. Metallic bonds don't occur between two different metals. They occur between metal atoms of the same element. So for example, gold atoms in a gold ring. So if we look at a gold ring, if I could zoom in and see all the atoms, what is holding the atoms together? That's a metallic bond. What are the properties of metals? Well, metals have a very high melting and very high boiling point because the bonds are extremely strong. And they're always capable of conducting electricity, unlike ionic where it was only in water. The reason they can conduct in the solid and liquid phase is because of mobile electrons. They have free-flowing, we call delocalized electrons, as you can see here in this animation. Because they have very low electronegativities, the electrons are not being held so tightly to the atom, and they kind of are delocalized, and they move around in between the atoms. And because we have moving charges, we can conduct electricity. So let's check your understanding. Can you distinguish between the three types of bonds, and can you classify a substance as ionic, covalent, or metallic based upon its properties? At this point, you should be able to identify whether a bond is being broken or formed based upon the energy being absorbed or released, distinguish between the three types of bonds, and classify a substance as ionic, covalent, or metallic based upon its properties.